Hello, teacher and classmates. My name is Luis Fernando Zamora Arce, and I'm going to explain you a little bit about how artificial intelligence are involved in the computer graphics file. First one, this is the presentation schedule. I'm going to start the presentation introducing some concepts in order to bring you a context to understand or have a better idea what we are talking about. Then I'm going to focus on determine the role of artificial intelligence in the process of generating and manipulating graphics. To reach this, we are going to talk about some other concepts that are involved in the process. Finally, I'm going to show you a little video, and then I'm going to give you some conclusions about the relation between artificial intelligence and computer graphics. So let's start.
To understand in a better way how artificial intelligence have an impact on computer graphics, we need to introduce some concepts as artificial intelligence, machine learning, and neural networks. Some of you maybe have an idea of the meaning of those concepts, but I'm going to give you a basic definition for each one. So let's start with artificial intelligence. Artificial intelligence is a branch of computer science that is focused on building smart machines capable of performing tasks that typically require human intelligence. So, for this reason, computer systems that implement artificial intelligence can simulate intelligence behavior. But how can artificial intelligence do this? In general, artificial intelligence systems works by ingesting large amounts of training data, using computer algorithms to analyze this data, searching for correlations or patterns, and using these patterns to make predictions about future states. As they go through the trials, machines learn and adapt their strategies to reach their goals, creating certain kind of knowledge. This process is known as neural network training. Neural networks reflect the behavior of human brain, allowing computer programs to recognize patterns and solve problems. Based on previously mentioned, the computer system that implements artificial intelligence can make intelligent decisions based on what it has learned, without being explicitly programmed. This concept is known as machine learning. Now, what is computer graphics? Computer graphics is a subfield of computer science, which studies methods for digitally synthesizing and manipulating visual content. It uses the computer and software techniques as tools to create and manipulate pictures on a display device. Graphics produced by computer systems have a significant impact in a lot of applications, but mainly they are used for generate multimedia content with different purposes, used for training, producing simulations related to academic issues, for example, aviation, and visualize measurement data. Also, a medical file to visualize and evaluate structures in a non-intrusive manner. For entertainment, to develop movies, animated movies or something like that, and for advertising. Some applications of computer graphics, like video game development, producing animated movies, or introducing special effects to something, especially requires photorealistic results. As we can imagine, the rendering process of those tasks involve a very high computational effort, and also is very high time consuming. So, for these reasons, I'm going to show you some examples of the benefits or advantages that the use of artificial intelligence gives to computer graphics. The first one is at Vienna University of Technology. There, neural networks have been developed, making much easier to create photorealistic pictures of a wide variety of materials. Normally, people related to graphics files have to manually adjust hundreds of parameters to make an object look photorealistic. With the neural network, even complicated material such as reflecting surfaces or turbid screens are not a problem. After a few practice rounds, the neural network has learned the physical properties of the desired material. That way, the system acquires parameters which can then be used to insert objects of this material into any image, matching any specific lighting much faster. This is a big step forward from game design and film animation to architectural visualization. The picture shown there was rendered by using artificial intelligence. So, as we can see, artificial intelligence can create images with high quality and involving less effort. The other example is NVIDIA. NVIDIA is showcasing a research that makes it far easier to animate realistic human faces, simulating how light interacts with surfaces in a scene, and render realistic images more quickly. Filmmakers and designers use a technique called ray tracing to simulate light reflecting from surfaces in a virtual scene. On the other hand, NVIDIA is using artificial intelligence to improve widely used rendering techniques like ray tracing and rasterization. Also, artificial intelligence is used to denoise the resulting images rendered by using ray tracing. NVIDIA researchers try to reach this goal by applying deep learning on GPUs to predict final images from partly finished results, or using the anti-aliasing technique. On these pictures, we can see that some parts have a bad resolution, so these techniques search to improve their image quality. Specifically, the anti-aliasing technique is based on training a neural network that try to recognize those pixels that give a bad resolution to the image and replacing them. Now, I'm going to show you a little video that explains some experiments that NVIDIA has developed involving the artificial intelligence on the generation graphic process.
The frames that you see is not rendered by the graphics engine. It's actually rendered by the AI technology that we built.
This is the first time we combine machine learning and computer graphics to do image generation using deep networks.
For training data, we're given some driving sequences of different cities, and then we use another segmentation network to extract the high-level semantics from these sequences. We have the UE4 engine to generate these colorized high-level layouts. Different objects were given different colors.
The network converts this representation to images.
I made my co-author to dance Gangnam Style which I don't think he would do by himself.
We find some good dancing videos from another person and then use my model to synthesize the dance move. That was created by machines, it's not me.
Okay, as conclusions, we can see that artificial intelligence can significantly contribute to a computer graphics file. Artificial intelligence helps in the rendering process, producing not only photorealistic scenes involving less computational cost, but also making it more intuitive and easier. So, artificial intelligence is a very interesting tool that can be exploited for graphic engineers to improve their realism and obtain very satisfactory results with much less computational effort. Also, researchers found that the results obtained by involving artificial intelligence in the generation of graphics are the same or better compared with traditional techniques. So that's all. I hope you enjoyed the presentation and thank you for your attention.